from Golden. So we can go 1, 2, 3, 4, 5, 6. We could go 6. P2. Good, I'm so glad I picked that. That is an answer. Or 6, 5, which is 30. Both of these will get you the same answer. And the reason why I can use 6P2 is because it's a word, permutation, order matters, and I'm not allowed to repeat letters, right? So words, you can always use the little p if you want to. 3 letters from chapters. 1, 2, 3, 4, 5, 6, 7, 8. 8P3, or 8 times 7 times 6, which is? Now the thing with all the words here, and you don't even know it, is none of these have repeating letters, because that's what we're starting to deal with today. So we are going to have to see if there's repetition. 4 letters from well, 6P4, or 6 times 5 times 4 times 3, which is? And 1 letter from value, 5, or 5P1, which is 5. Okay, in a 10-team basketball league, each team plays every other team twice. Now this has to be the key thing in order to be able to use the P. We're going to talk about these with combinations later. This only works if they play every other team an even amount, so twice. Twice means 1 home and 1 away, so that means that order matters, right? Home and away are totally different. How many teams are there? 10. P, and then this is the catch. The P means that home and away matter. The 2 that we're going to put after this doesn't mean play twice. The 2 we put after this is how many of those basketball teams play each other. So for example, if I wanted to do X number of people, I would have to choose people from the people, right? Like it would be a P8, P2 would be 8, and I'm choosing 2 people, correct? Letters. I have 8 letters and then P3. 8 letters, I'm picking 3, correct? So here, I have 10 basketball teams, so this is a basketball team, correct? So I'm going to pick X number of basketball teams play. In basketball, how many teams play? 2. So that's where the 2 comes from. If it was like there is a soccer game where 3 teams play at once, I think it would be hilarious. But anyways, you have to put a 3 there, correct? So it's how many, so if you're picking golf clubs from golf clubs, that's what it would be. Principals from principals, students from students, teachers from teachers, boys from boys, right? This is basketball teams from basketball teams, so you have to do 10P2. What do we get? 9. And then this one, in a competition on the back of a cereal packet, 7 desirable qualities for a kitchen. Example, spaciousness, versatility, etc. Must be put in order of importance. So they're giving it order of importance. That means I can use blanks. Do you agree? I can use P too, as long as I'm not repeating. The number of different entries that must be completed in order to ensure a winning order. So 1, 2, 3, 4, 5, 6, 7. So how many qualities would I have for the first blank? 7 then. 6 then. 4, 3, 2, 1. Or I could go 7, P, 7. Either way, it's 5,040. Is it not? Am I wrong? What is it? No, because P makes home and away. It makes you have 2. If I did, now watch this. This is a good question. I'll come back to this for this. If I do 10P2, that's a home and away. If I do 10C2, that's saying I'm not giving it order, okay? So can everyone put 10C2 into their calculator? I mean, home and away mean the same thing. So what do you get? You get 45. So this would have to be multiplied by 2 to make you have 2 teams play, like them playing twice. So the P encompasses the twice in it. So that's why you can only use P if they play twice or 4 times or 8 times or 16. Because if they played 4 times, you have times that by 2. So I often just stick to this one anyways, because I can just go 10C2 and then times by how many times they play. But the P also. Okay? Same as times 2. All right. Permutations with repetition. So up till now, we've had no repetition. Now we will have repetition. So you can have them either repeat or not, and you have to spot that as well. So consider this stuffies example from the last lesson. There were 6 ways to arrange the 3 stuffies. And we arranged them, right? We put them in order. We lined them up. What would happen if instead of having 3 different stuffies, we had 2 of the exact same kitten and a puppy? Okay? So when we did the other ones, if we had 2 kittens and a puppy, we know the other one was 6, correct? We had 6 different. So here if we went kitten, kitten, puppy, is this different? Kitten, kitten, puppy? I swapped the kittens. Does that look different though, because the kittens are exactly the same? No. So that case is gone, correct? Then I could go kitten, puppy, kitten, and I could swap the kittens again. Kitten, puppy, kitten. Do those look different? No. So that's gone too. And then I could go puppy, kitten, kitten, and then I could swap the kittens, puppy, kitten, kitten. And that's gone too. So now I only have 3 cases instead of 6. Now, it would really suck if I had to go through every single case and then cancel off all the ones that matched, right? Like, especially when you have like 1,063 cases or something, you're not going to be able to do that. There is a way easier way. What you do is you treat them like they're all different. So on the top here, I'm going to treat them like they're all different, like I can tell the difference between the kittens and kittens, correct? So how many stuffies would I have for the first blank? 3, correct? Then I would have 2, and then I would have 1, which gets me 6. That was the total we had before. But we're always going to divide by the number of repetitions. So I have 2 kittens. We agree? Is that true? So I'm going to divide by 2 factorial. If I had 3 kittens, I'd divide by 3 factorial. If I had 4 kittens, I divide by 4 factorial. Okay? So I treat the top like they're all different, and then I divide by factorial the ones that are the same. And this gets me 3. Same answer. Okay? So I want to prove this to you in a different way. You can put your pencils down. I just want you guys this to solidify more in your head. Okay. I have the word plob. Isn't it great? It's a great word. I could have used blop, but I used plob instead. Okay. Looking through your soul. How many ways can I rearrange plob? What do we do? 4 then, 3 then, then I get 24. Yeah? Get ready. It's going to get crazy. Great word. Doesn't even have a vowel. No, why? It's good. How many ways can I rearrange ploop? 4, 3, 2, 1. 24 ways? We'll have to divide by. I have 2 p's, so what? 2 factorial, and I have 2 l's, 2 factorial. Do you want to know what I did in my day, which is probably where your brain's going right now, and if not, I'm alone, it's fine, I can be alone. When I learned this in grade 12, I wanted to put a 4 down there. But if you put a 4 down, you're saying you have 4 letters that are the same, correct? And I was like, well, that's the same. No, it's not. 2 factorial times 2 factorial is the number 4, correct? 4 factorial is 24. So if I put 4 factorial, I'm dividing by 24, which is substantially larger, correct? It's not 4 factorial. I have to write it. So if I had like now 3 O's at the end, I would have to go 3 factorial, right? Okay? So now this is going to be 24 divided by 4, which is actually 6. You don't believe me? Look. 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 Yeah, that's what I'm going for. And then and then 6 words. Words I say these Look at my own language. Start it. All right. Let's go here. In the mountainous regions of India, China, Nepal, and Bhutan, it is common to see prayer flags. Each flag has a prayer written on it. A color is used to symbolize different elements: green for water, yellow for earth, white for air, wind, blue for sky, space, and red for fire. How many different arrangements of the same prayer can you make using all 9 flags? So they're telling me I can't tell these apart, right? They're saying the flags are identical. Do you agree? So if they're identical, I immediately do this. Not getting me, diploma writers. No, Mrs. Lepp, you aren't getting me either. Bro, I'm going to see there's repetition here. And I'm going to see that I have 2 whites. Boom. And then I have 3 blues. Boom. And I have 2 reds. Boom. Yeah? Do that right away. Because the people who do not do that right away half the time forget to do it. Okay? You get so excited that you can do the top that you forget the bottom exists. Now, do you think the answer to forgetting the bottom existing will be on the diploma or on my unit exams? Not having the bottom? Do you think the answer will be there as an oopsie, though? Yeah. 100% will be there as an oopsie. Okay, so if you forget it, okay, we don't want that. We don't want you to take that off. So, the top, I treat them like they're all different. Does it say I have to start with like a red flag and end in a blue flag or anything like that? No. So how many flags do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Can I repeat the same flag? Do I have like an unlimited number of flags here? Can I like do like all red? No. So how many do I have for the first one? 9, then 8, then 7, 6, 5, 4, 3, 2, 1. So technically, I have 9 factorial over 2 factorial, 3 factorial, 2 factorial. I would love everyone to type it into their calculators and see if they get the right answer. Because so many people type this in wrong. If you have the fancy pantsy calculators, so the fancy pantsy ones are the charging ones, or a lot of these ones. And how do you know that TI-84 pluses are fancy pants? You know they're fancy pants if the exponent pops up. Like when you press the exponent button, and the exponent pops up, so you get like 3 to the power 4 or something like that. If you get 3 rooftop, 2, you don't have any fancy pants calculators, you're going to have to use brackets. So, fancy pants calculator people, listen to me. So the plugging in calculator people. The people with the plug-in charging calculators. Can you guys do me a favor right now? Grab your calculators, fancy pants chargers, and go alpha link. It's the button right beside. And what pops up? A fraction. Type it in. Okay? Alpha link. You get a fraction button. You immediately type it in. If you have these ones, and you have the exponent where it pops up, you just get the fraction in a different way. You're going to go, so now if you have the TI-84s, check this out. You might have it. Okay? You have the TI-83s. So sorry. These brackets, you don't have it. Okay, you're going to go alpha. Alpha is the green button on most of your calculators. Alpha, y equals, enter. And you get a fraction. Like an Oprah. You get a fraction, and you get a fraction, and you TI-83s, you get a fraction. Okay? So the fancy colored ones will do alpha y equals enter. That'll work too. But alpha link's just so much faster. It's right beside it. Okay? If you, okay, put your calculators down for a second. Let's talk to you about your calculators. You guys trust your calculators implicitly over yourselves. You're like, my calculator's way smarter than me. No, it's not. And your calculator's operated by you. Therefore, it could be an error on you still with your calculator, right? What we can guarantee that our calculator will always do is order of operations. That bad boy will always default to order of operations. What is programmed to do? It can't not. You know how like they give those stupid things where it's like, give me the answer to this, and they give like an order of operation question, and like every 40-year-old can answer it right because they can't remember the order of operations. True that. If they typed it into one of these calculators, it would come out right because that calculator will do order of operations. Okay? So, if you have the fraction button, please use it. It will do it correctly, because you will put it in the way it looks, correct? If you don't have the fraction button and you type it in like this into your screen, you will get the wrong answer, because your calculator is going to do order of operations. So let's think about that. You guys know the rule. It does multiplication and division in the order that it's in, correct? So what is it going to do? It's going to go 9 factorial, take that answer, divide it by 2 factorial, then take that answer, multiply by 3 factorial, take that answer, multiply it by 2 factorial. Is that what we want it to do? No. So if you have the TI-83s, you have to put that in brackets. Because the coolest thing about your calculators is that they will always do order of operations. So if you want something done first, what do you have to put it in? Brackets. It's going to do brackets first. Always, always, always. So you want something to happen first, you put it in brackets, your calculator will do it first. Because it doesn't have a choice. It is programmed to do bedrooms. That make sense? Okay. I don't know the answer in my head. What is the answer? They started talking, sorry. Okay. All right. So guys, here we have words. What do the words have? Repeating letters. Rewrite your word. Okay? We're going to go V. Now this looks stupid, but it works for twofold reasons. We're going to rewrite out the word, and we're going to stack letters that double or triple. Okay? For twofold. One, we don't miss one that doubles and triples, which happens a lot. Two, we're stacking them, and our brain will be like, why the heck are we stacking these? And maybe it'll remind you to do the denominator. Okay? So V, A, N, C, O, U. Haven't come up with anything yet that doubles. Oh, V. V. Do you see how I stacked it? ER. So immediately before I even do this question, I have a 2 factorial in the denominator. Do you see that? Genius idea. It was not mine. But I will use it forever. Okay? So how many letters are in Vancouver? 1, 2, 3, 4, 5, 6, 7, 8, 9. Fun fact, I count twice always. 1, 2, 3, 4, 5, 6, 7, 8, 9. Confirm that I did not count that wrong. Okay? It has 9. It doesn't say it has to start with a V. It doesn't say it has to do anything. It literally just says Vancouver. 5, 6, 7, 8, 9. So I just need 9 blanks. And I need all 9 letters used up, right? That's it. So how many are going to be in this first blank? 9. Now some people are like, but if the 2 V's are in a spot and I move them around, then they aren't going to look different. That's what the 2 factorial deals with, right? It gets rid of all those problems. We treat the V's as if we can tell them apart. And then this gets rid of all the places where we can't. So we have 9 then, 8 then, 7, 6, 5, 4, 3, 2, 1. And we get 9 factorial divided by 2 factorial. And what do we get for an answer?
881,440.
Okay, then we have mathematical. M, A, T, H, E, M, A, T, I, C, A, L. So before I even do the question, I have 2 factorial, 3 factorial, 2 factorial in the denominator. You see that? Should we write it down unless you've already done it? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we'd have 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Do I actually have to show that, or could I just do 12 factorial if I know there's no way? You just do 12 factorial, right? So we're going to get 12 factorial divided by, now if you use the fraction button, you don't need brackets. If If you don't have a fraction button or you choose to revolt against it, you have to use brackets. There are some people who choose to revolt against it. What do we get? Big word. All right. Here we have the word answer. Determine the number of different arrangements of 6 letters in the word answer. So from now on till eternity, I will always rewrite the word up, right? A-N-S-W-E-R. If I just rewrite the word and nothing stacks, cool. I have a word without doubling or tripling letters, right? So without restrictions, what would this one be? 6 factorial, or 6p6, right? Those are the same thing. 720. Same answer. Begin with an S. How many S's do we have? 1. Then how many letters do we have left? 5, 4, 3, 2, 1, which is 5 factorial, which is 120. Begins with a vowel and ends in a consonant. How many vowels do we have? 2, A and E. So we have A and E here. We have 2. We have to box and hold because it's a word. Consonant, we have 4. We have N-S-W-R. Then how many do we have left for the middle? We've used up how many letters? How many do we have left? 4, yeah. So 4 then, 3 then, 2 then, 1. So it's technically 8 times 4 factorial, which is 192. And flip over. The 3 A, N, S are adjacent in that order. So they have to be in that order. So how many do I have left for here? 1, it has to be an A. 1, it has to be an N. 1, it has to be an S. How many letters do I have left? 3, 2, 1. Am I done? What do I have to multiply by? How many spots can I move it? 4. Because I have the 3 letters at the back, correct? 1, 2, 3, 4. One more than the hook together. So if you look here, this is a 3. After the hook together numbers, it'll always be one more. 4. Because I have those 3 spaces. This counts as 1, 2, 3, 4. Right? 4 other cases that would look the exact same. So 24. Then this one says that have the 3 letters A and S adjacent but not necessarily in that order. So we could have now 3, 2, 1, because they can be in any order. 3, 2, 1 letters left over. And what do I have to multiply by? 4. So it's technically 3 factorial, 4 factorial. What do we get? Is that 144? I think it is. We've got this answer a few times. Okay, what's the difference with ANSWI? There's 2 A's. And how is there 2 A's? Because I had the word answer and I wanted a doubling letter, so I took the R off, put an A there. That's how we got ANSWI. You are welcome. That is my thought process. So, A-N-S-W-E-A. This is going to have a 2 factorial on the bottom. This is going to have a 2 factorial on the bottom, etc., etc., etc. They're all going to have that. And people say to me, well, what times do they not? Never. Never, I say. Not in the way that we do it. It will always have that on the bottom. So, without restrictions, how many letters would be on the top? 6 factorial. And we would get 360. The next one says that begin with S. Has to begin with an S. How many S's do we have? 1. Now, guys, if it said begin with an A, what would I put in that blank? 2, because you treat the A's like they're different, remember? And then you get rid of them by doing the 2 factorial cases where they're not. So we do treat them like they're different on the top, you can know that. So begins with an S, and then we have how many letters left? 5, 4, 3, 2, 1, blast off. So we get 5 factorial over 2, they could say. Now some people say, well, why can we drop the 2 factorial sign, the factorial sign off? Because 2 factorial is 2. 2 times 1 is 2, right? So it's the only one you can drop the factorial sign off. Because 3 factorial you can't, it is 6. So this is 16. Begins with a vowel, ends in a consonant. Well, I know it's going to have a 2 factorial on the bottom. How many vowels are there this time? 3. Do I care that I can't tell the A's apart? No, because I treat them like I can. How many consonants do we have? 3. How many letters have we used up? 2. How many letters do we have left? 4. So we're going to put a 4 here. 3, 2, 1. I don't know what the answer is. 12. What do we get? Want to wait, maybe? Doing 12 times 9 in my head and wasn't running. My math was not mathing for a little bit. Okay. That have 3 letters A and S adjacent in the order A and S. On the bottom, you're going to have 2 factorial. I put it always. So it needs to be in the order A and S. How is this different than the last one, though? The first blank has what? How many options? 2. Because there's 2 A's. Then 1, then 1. How many letters have I used up? 3. What if it said adjacent in the front? When I was done, I'd be done, right? I'm done filling these blanks in, but it doesn't say that. So I have 3, 2, 1. It says adjacent. It doesn't say adjacent at the front or start with them or anything like that, right? So what do I still have to multiply by? 4. So I get 24. The 2 should end in canceling. All right. You guys are going to do example 5. Example 5 has no repetitions. Just treat it like normal. So there's going to be no denominators, right? Some of these will have repetitions, some of them won't. Well, you do example 6. It has the word Canada. What does Canada have? 6 letters and 3 A's. Okay, so it's going to have a denominator. Don't worry about 7. I have to draw something in there. So do example 5 and 6. And then I want you to flip here to the your turn. We're coming back to the other things after. So go to the your turn, please. Don't cross out those other ones that are in between. We're going to do those ones tomorrow. 1, 2, 3, 4, 5. Those are all due for tomorrow. I'm going to put a homework check in Google Classroom where you have to post these. We're going through them, so get going.